Hi, pre-algebra friends. Before I get started on today's lesson, I just thought it was important to show you a picture of my dog Reese and to show you what she's doing right now. So when you hear weird squeaky sounds in the background, you will know that it is the dog actually chewing on one of her toys. She just got a bath tonight and she's pretty traumatized. She smells like wet dog still, but she's pretty traumatized over getting thrown in the tub by me and Nathan earlier today, and so she clearly needs to chew on her toy, and she has to be right next to me. So anyway, that is going to be the squeaky sound that you hear. She's just resting right now, but I'm sure you'll hear it in just a little bit. So anyway, today, now that we got that out of the way, we can focus on solving volume problems. And yesterday we were talking about surface area, and I want to make a difference between these two things when you so that you don't get them confused when they're all put together. When you're thinking surface area, think about wrapping a present. It's the outside, and yes, we're finding area, which is usually like the inside of something, like when we're talking about a garden or something like that. But yes, we're talking about all the space in it, but we're also talking about a 2D shape when we're doing area of something like that. Okay, so this is usually a 2D shape where we are finding, what is the area that's taken up by all the space in here. And then when we have a 3D shape, we're looking at, okay, what's the area of that top part? And you're doing, like I said, wrapping a present. You're looking at the outside of the shape. Do you hear her now? She's back to chewing. So, and today we're going to be looking at volume. And volume is different. Volume is going to be where we're looking at how much space something takes inside. So we're only talking 3D shapes right now, and you're going to be looking at how much can fit inside of something. So this time when we're thinking of volume, you're going to be thinking like how much can fit. I probably could have done this a whole lot better, and you know me, but how much can fit into this shape on the inside. So I kind of made a, without meaning to, I kind of made a triangular prism, but think of it as like a Toblerone bar or one of those candies that has like all of those like triangles inside of it, like how much could fit inside of there. Or think about an Amazon box. How much could you fit inside of an Amazon box for a triangular prism? So so volume would be inside, and surface area would be like how much wrapping do we need to put on the outside of the box, and yeah, volume inside. So there's just formulas to memorize again. We're going to be doing different shapes and different formulas that would actually work for the different shapes. That's a nice thing about this. And so, like I said, the volume is the inside of something. So if we were doing this triangular prism, then you would have the two triangles on the outside, and we would be wanting to know how much could be filled in all of here. If I would fill that thing up with either pieces of chocolate or whether it be stuffing of some sort, like packing, like the little fuzzy things that you put inside a package or something, how much could fit. So there's a formula for it, and volume is a capital V. So V stands for volume. Do you hear her squeaking? And there's a capital B, which stands for, the capital B is very important. It is the area of a base. Okay? So we did lowercase b the other day when we did like area of a triangle. We did, oops, I'm sorry. Let me go back. When we did area of a triangle, we did lowercase base times height. This capital B is very important. It stands for the area of the base, whatever shape it is. Okay? So volume equals area of the base times the height. Let me go back and erase all this for you. So we have a lowercase b, which just stands for base, but that capital B stands for area of the base. So let me do that again for you. Volume equals area of the base times the height. So let's take a look at this shape over here, okay? And so I have a triangular prism. Let me see if I can make this bigger for you. I don't know if I can zoom in on it or not. I can't. If I'm looking at this triangular prism, then I'm noticing that I have the triangle shape as my base, right? And I have 6 feet here for my triangle. And I have a height in here of 4 feet. Now, this capital B means I have to find the area of this base. And how do I find the area? Well, area of a triangle equals base times height divided by 2, right? So I would do 4 times 6 divided by 2, which equals 24, divided by 2, which equals 12. So my area of this triangle, my area of my base is 12. So I had to do all of that work to find out that capital B. Notice it's different than this lowercase b right here. So my volume equals 12 times my height, and in this case, my height is not the same height as this height in here because this was the height of my triangle. In order to find the base, I have a different height. I have a height of my whole shape. Do you see that there? My height of my whole shape is 9. So my volume equals 12 times 9. And so therefore, my volume equals 81. Because 12 times 9 equals 81. And in this case, it is going to be feet cubed. Volume always comes in cubed feet or inches or whatever it happens to be. The reason why it's cubed is because we were multiplying feet times feet when we did this base times height, and then we multiplied it again by another feet when we did the height over here. And so this was, when I got my area, it was 12 feet squared, right? And then I'm going to multiply that by 9 feet. And so 12 feet squared times 9 feet is 81 feet cubed. So I know that was a lot to take in. Rewatch it if you need to. Talk to a partner if you need to. But I'm going to go over another problem with you in just a second. Whenever we need to find the volume of something, a prism, we are going to find the same formula. That volume equals the area of the base times the height of the whole shape. Okay? So, in this case, I have a trapezoidal prism. And so, in order to find this area of the base, I've got to find what my bases are, right? And in this case, they're a trapezoid. So I've got to find area of a trapezoid equals, remember this? Yep, it is base 1 plus base 2 times height. And remember, it was 1/2 base 1 plus base 2 times the height because we were going to split those two up. Remember that? So that's in our formulas. You could always go back and look at that. But area of a trapezoid equals 1/2 base 1 plus base 2 times the height. And so I've got to go ahead and plug that in. That all stands for this capital B right here, my area of my base. Okay? Since they're trapezoids, I have to use this formula. I think it's a couple pages ago. I think it's in order to find the area of a trapezoid, I think it's like 2 units ago, or 2 lessons ago, okay? So I'm going to plug everything in. 1/2, my base 1 is 6. Looking at here, my base 1 is 6. She's really going to town on this thing, huh? My base 2 is 4 feet because I see it's the same thing as the top up there. So I've got 6 plus 4. And I'm going to times it by my height. My height is not, in here, since I'm talking about the trapezoid at this point, this height that I'm talking about is different than this height up here. Okay? This, I'm just talking about the trapezoid because I'm still handling this B section here. Okay? So I'm only talking about the height of the trapezoid, and looking at here, the height is 4. So I'm also going to do a 4 right here. Does that make sense to you? So I'm going to do 1/2 times 10 times 4, and I know that 1/2 times 10 equals 5, and I'm left with 5 times 4, which equals 20, and my unit for that is 20 feet squared. Keep on going backwards like that. Sorry about that. I keep on touching that little arrow. So 20 feet squared. So now I can erase all this, all right, to keep this and replace. You're not going to erase that. You're just going to keep that work on the side. I just need more space to work on. Okay? And so I now know that this base right here equals the area of my base right here. I'm going to write my next line. Volume equals 20 feet squared times my height. And this time we're back to the whole shape again. We're looking at the volume of the whole prism. And so I know that my height is what connects my two bases together. And so in this case, my height is 9 feet. So I have volume equals 20 feet squared times 9 feet. And I'm left with 20 times 9, which equals 180. And feet squared times feet, this should be just feet, sorry about that, feet, equals 180 feet cubed. Does that make sense? 2 feet here times 1 foot here is 180 feet cubed. Okay? Sorry about a little mess ups here and there, but I'm not going to do my whole video on that part, and this is not very good editing features on this program. Okay, let's go over to find the volume of the prism. You can work on that one alone. There is an answer for the answer key. I just had to make an edit right there, so if it was a little choppy, sorry about that. And the dog is still chewing away, so sorry about that as well. But now we're going to move into volume of a composite solid. And a composite solid is just when you have more than one solid put together. It's nothing tricky. We just have to find the volume of all three shapes and then put them together in the end. Our volume formula is always going to stay the same. It's going to be the volume equals the area of the base, that capital B, times the height again. And so I'm going to take care of this figure over here, that rectangular prism. And in order to find the area of the base, I know that the area of the base is going to be that length times width, okay, equals length times width. And in this case, we're going to have 3 times 4. 3 times 4, which equals 12. And so the volume of this figure is going to be volume equals 12 feet squared times my height. And in this case, we're now talking about the height of the whole thing, and it's that 3 feet up here, times 3 again. That can be a little bit confusing, but it's 3 feet again. The reason why I keep on writing the units next to it is so you realize why we're getting feet cubed instead of squared. Now that we're dealing with volume, it's always going to be to the third power. And so after we do this, we end up with volume equals 12 times 3, which equals 36 feet cubed. And so that is the volume of this shape over here. Got it? And since this shape is the same, we're going to have two of those. We've got, I see that the numbers are exactly the same. The measurements for that are the same. And so we have two shapes that have a volume of 36 feet cubed. Okay? And now we are going to take a look at the next shape that we have, that one in the middle there. And we still have our same formula. It's volume equals area of the base times the height. And in this case, we have this, the base is actually what's connected to the two side rectangular prisms. And so it's hard to find the bases sometimes. There's only two bases. It's going to be the same measurement on both sides. That's how I know it's the bases. But look in here. Do you see how where it connects, right in here and right in here, are going to be the same size, and then you have like 4 sides that are kind of like wrapped up around that. And so those are going to be our bases actually. So my area of the base, they are going to be squares, and it's going to be area of my base equals length times width. You could say, or side squared, or whatever it happens to be, since they are squares. And you see that it's 1 foot times 1 foot, which equals 1. And so my area of the base actually equals 1. So I'm going to replace this in here. And so I'm going to say volume equals 1 times my height. Now, remember that my height is not that individual shape now. Now it's the height of the whole thing, the whole shape that I'm looking at, and that is 2. And so my volume equals 2 feet cubed. And so I've got to take my 36 that I came up with from before, plus 36 that I had before, plus 2, and I add all of those together, and I end up with 74, and it's going to be feet cubed is, that's a 3, feet cubed is going to be the volume of the whole thing, okay? It's going to, if you have trouble finding which ones are the bases, let's talk about that. It's the two things that are repeated with each other. That kind of takes care of this lesson. Feel free to chat with a friend to find this. Your work right now that you need to complete is to do the your turn on page 291, that one down the bottom for that composite figure, and the your turn number 5 on page 290. Try both of those out. One is a regular figure that's a trapezoidal prism, and the other one is a composite figure that's a rectangular prism. This is your base right here. This is your base, and then your triangle is the base here. Don't forget that you have to do the area of the base for that, and you're going to have to do the triangular one and the rectangular one separate. So again, your work for today is the your turn problems. And then go on to the guided practice. Do not feel like you have to use the book's way of doing things in here. If your brain doesn't work that way, you can just do it on a separate sheet of paper if you want to. But definitely check in with your answer key and see if you are understanding the concepts. If not, please talk to someone else in the class. This guy in here is probably going to be a little bit tricky. Use the answer key. Remember that because we have two shapes on top of each other, you do not have to double up on the bottom side. Well, it's a different situation now because now it's volume, not surface area. So actually that won't affect anything this time around like it did with surface area. Make sure that you check those answer keys like I said, and we will talk tomorrow if you have any additional questions. Your homework for tonight is going to be page, let me see if I have the pages in here. That's 292, that's 293, so it's going to be 294 and 295. Choose your challenge if you would like to do the hot problems, but that is for homework. Thanks so much, guys. I hope you had a great day. Thanks for dealing with the dog. And yeah, she made it all the way through that. So she actually took that ring and, well, she bit through the whole thing. So she must be really upset after her bath tonight. Anyway, I'll talk to you guys on Wednesday and can't wait to see you then. Take care. Bye.